This is page 22, number 35, an explanation. So in this problem we have two rays that forms one angle. Now we have three rays and we have 1, 2, 3, 4, 5. But I've written three angles. Now let's look at why that is. If you look at that, we've traced an angle twice. So you have to account for that. So really, of our unique angles, we have 1, 2. Now this red and that green, the red and the green are both the same. So that's 1, 2, and then 3 is going from the middle piece down. So that's my three angles. Now when we have four rays, watch out for the duplicates. 1, 2, 3. That's a duplicate. 4, 5. Duplicate 6. So now I have 6 angles. Again, make sure you guys notice that I'm duplicating some of them. These first few ones, yes, I went through and I drew out the duplicates. I'm not always going to do that. I'm not going to do that in our next example. So now when I have 5 rays, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 angles formed. Okay? Now let's now notice what a pattern is. As we increase our rays by 1, let's look at how the angles increase. And when you're looking for a pattern, the first thing that I would look for is a common difference. So our first difference is 2, next is 3, and the next is 4. So our hypothesis is going to tell us that the next one should be 5. So when we have 6 rays, we form a total of 15 angles. And I didn't draw that out. That's going to be hard for us to tell. Now the next part is, what's the formula? And I explained this formula. We have n rays, and that's paired with n minus 1 of the other rays that we have that we can form an angle with. If you look at it, when you have 3 angles, you can only pair with 2 other rays to form an angle. So that's why it's n times n minus 1. And then we divide by 2 because of the duplicates. And again, if you look up here at where we have 3 rays and 3 angles, okay, there were some duplicates in there in the red and the green angles. And the same thing can be seen with the 4 rays and 6 angles.